Good morning, everyone. Welcome to class today. We're going to be learning about constructing a phylogenetic tree for the Beasties lab today. And I wanted to introduce a few things about how to go about setting up this lab so that when you actually do partake in it, you're not getting confused later. So please follow along. And again, if you have any questions, please feel free to email me or we can start a group chat on Zoom sometime later today. So this lab is going along with the instruction that you received earlier on what a cladogram versus a phylogenetic tree really is. And we're going to be looking at relationships among organisms and basically looking at descent from common ancestors as well. And we can assume that this is all about what's called divergent evolution, which is evolution when we have descendants from a common ancestor. So in this exercise, our goal is to reconstruct the evolutionary history of a group of imaginary organisms known as beasties. Sorry, these things aren't for real. And so they're a very morphologically, that means body forms are different, diverse group. And the analysis you're going to take part in is going to be based on this diversity. So we are going to also be, this is kind of exciting stuff, inferring the most parsimonious, which means the simplest phylogenetic tree based on the findings of similarities and differences among these organisms. So please follow along, and we're going to get started on how to do this lab so that you can go ahead, finish it on your own, and then get your tree and your questions done before you submit and hopefully feel pretty good about this stuff. So again, if you scroll down, your second job today is to read the directions on your own before you begin personally. But we are actually going to take a look at the tables and start constructing a comparison table based on the organisms below and based on some of their traits. So table 2 is the comparison data you want to fill in quickly. We're going to go through one example together. If you look right above that, table 1 is actually the beastie's characteristics. Now the way this works, as we'll see, if you look at the organisms below, is that we have an outgroup and then we have 6 other beastie organisms that may or may not have similarities to that outgroup. We have to look for those similarities or perhaps differences depending on how evolution has taken place. So this organism here is our outgroup. And the other 6 organisms are all going to have changed over time, assuming that mutations have occurred and perhaps been selected for in their particular environment. So going back up, if that guy is our outgroup, we are going to take a look up here at table 1 and understand from table 1 that everything the outgroup has is automatically going to be characterized as a 0. So they filled in the comparison data table for us already with the outgroup being zeros all the way through for that outgroup, which should make sense. And again, the names of those characters we're looking for or traits we're looking for are listed in table 1. And so some are either absent or present. Other traits will be, classified further by flat or sharp, simple or branched, round or pointed. So take a look at that table 2 when you need to as you get there. So our first organism in table 2, it wants us to compare to the outgroup, is organism A. So if we scroll down and take a look at organism A, we can see it definitely has some similarities and differences as we check that out according to the outgroup. And so there are some things that have stayed the same. An example of that, if we highlight that, would be the legs. Those are the same in both of those organisms. There are also a few other things that are similar in both organisms. So if you take a look at those are the spots, the beard, and the tongue. The spots are absent, right? There is no beard. You'll see what a beard looks like if you look at picture B, right? For that beastie, he has a beard. And then the other one being tongue, some of them may have tongues. Obviously, these two do not. So we are going to look at the table above and look at their similarities and differences and classify those with numbers. Remember, it's going to get a 0 if it still retains that characteristic as the outgroup has. But if it's different, it's going to get a 1. So let's go ahead and take a look first at eye size. One thing to take a look at here with eye size is that it's definitely somewhat dramatically different in picture A than in the outgroup. So that is going to get a 1 for the eye size here because it is different. And they tell us, if you look at the table, that for large eyes up here, right, that is going to get a number 1 in the classification. So if we go through this then, teeth would also get a 1. Those are definitely sharp teeth there, and they differ than our outgroup for sure. The next one being antenna, all right, is definitely something that if we look at the table is branched. So branching antenna right here is different than the outgroup. That will also get a 1. Then we look at the fin. If we look at our table, it tells us that fins are either absent or present. All right, and if we take a look at the outgroup, there is no fin, whereas in our group A picture, there is a fin in that taxa. So we're going to go ahead and put a 1 for fin as well. Then we're going to fill out the rest accordingly. Feet are 0. We said those are the same as the outgroup. That's when we do want to put that 0 in there. All right, the tail is different again. Take a look at that tail. Definitely different in both pictures. And according to what it tells us, it's either looped or brushy. So looped, some organisms may still have loop tails. Picture A is not one of them. So that is going to get a 1. And then the other 3 are 0s. As we said, those do not change. So that is how we'd go about giving those classifications and the scheme of that classification to picture A. You will do the same for B, C, D, E, and F. Then when you get to the next table, this is called a ranked data table. So we'll do one of these together as well so you get the hang of this. What you want to do here is make sure you place those beasties in order based on the number of differences with the outgroup. And so the outgroup we can simply fill in again if you want is all 0s. Everything again stays the same as given in that picture. But your job now in this table is to start looking for how we can rank these based on how many changes. We assume those changes are likely DNA mutations that gave rise to phenotypic changes, right? Think about that as well today. And as those changes occur, we want to list them in order as they occur with respect to the outgroup. So looking at all of these similarities and differences, if you check those out for a second, when you do this, you will see that actually the organism that is most similar to the outgroup is organism E. And that is going to be given to you so you can use this to classify the rest of them. I will tell you that if you do this right, E is only going to have eye size and tongue that are actually different than the outgroup. All of the rest of those traits are identical. So because there have been only 2 phenotypic changes, whereas all the others will have many more than just 2, we do want to list that one as the second one after the outgroup. Now, if you have any that are the same, let's say maybe 2 of them have, and I'm not saying this is going to happen, but it could, 2 of them have 4 changes from the outgroup. Please do not worry about the order of them then. That's random. We wouldn't be able to tell from just this information which one likely came next in a phylogenetic or ancestral tree. So your job is to just place them in any order then with respect to the outgroup if they do have the same amount of changes. Not saying that's going to happen, but it's possible. Then we scroll down. Your next job is to go ahead and place those beasties in their phylogenetic tree. Notice you're going to put their derived characters on the tick marks as we've been talking about throughout this week's lessons. So the only 2 tick marks that sometimes cause students a little bit of trouble are these 2 right here. And if you're listening, I will tell you right now, I do not care about the order you place those in. What we have evidence for today is not going to be enough evidence really to tell us the placement of those in their proper order. So please just place them wherever you want to. It really doesn't matter which one of those comes first or second, but note that they do need to go in that proper, area of the tree as opposed to above or below it. They need to be in that middle area, but their 2 placements don't really matter. So in other words, these can be interchangeable right there. Okay, hence the little arrows. Now, if we scroll down, once the tree is all set up, and don't forget again with your tree, you want to put the outgroup right all the way to the bottom left because that's the organism that is going to be the most different from the rest. And as we have more and more similarities and more things in common, we want to work our way up and to the right as we've been discussing. When you are done with your tree, if you scroll down, I would like you to answer these last 5 analysis questions. Please feel free to do a little bit of outside research if you'd like to, or as I said earlier, another great way to go about learning more in this lesson, really all week with what we've been taking part in, is you can read a little bit about cladograms in your book, and that is on page 538 it begins, and that's chapter 18, section 2. So your online text could be a really great resource for this information as well, although you might not necessarily need it. So I'm looking for some well thought out answers for A through E here. E is really just a listing of 2 traits that are going to be unique to a particular type of beastie. And you can list any 2 and then just explain to which taxon it belongs. So if you have any questions on this, please feel free to start a discussion board with your lab partners or anybody else in class that you'd like to in Schoology. I am absolutely fine with that. I think it would be a wise decision. And or feel free to email me today. And hopefully by the end of the day, you guys can feel good about this, get this submitted. And this is the only other work today that I need you to get done. There will eventually be a key posted so you can check your work in more detail, but that might not come until tomorrow. All right, thank you, and I hope you guys are all doing well. Miss you a lot.